Hello everyone. In this tutorial, we are going to look at purely capacitive AC circuit. And in purely capacitive AC circuit, the current leads the voltage by 90 degrees. So I have some formulas here that we will be using. And what I've done here is I've have the circuit connected already. I have a voltage of the peak voltage for the source as 1 volt, and then the frequency is 1 kilohertz. Also, I have my probes connected, the voltmeter and the ammeter here connected, and there is a capacitor with capacitance of 1 microfarad. So if we simulate, we shall take some measurements, and by those measurements we shall calculate and see if truly the current leads the voltage by 90 degrees. So let's go to the simulation. So this is how it's being simulated here. The current is the blue wave, the blue dotted wave, and then the voltage is the green wave form. So what I'm going to do is I'm going to change the cursors here. So I will let cursor 1 stay as voltage, and then cursor 2 stay as current. Now I will stop the simulation, and then we will take the measurements. So I just want a full schematic, and then probably that will give us a broader view of it. So I've just taken the full graph out here. Now I've already connected. What it is that I have this to measure the voltage when it's at 0 volt, and then here when the current is also at let me just do it this way. So I'll take the current when it's maximum here, and then the voltage when it's and I'll take the current there, and then I'll take, so I've taken both when they are at 0 degrees, and when they are both at 0, you will realize that it's down here, the current is rather leading the voltage. If you look at it in time, voltage is 0 here, the current is 0 here, and the current is leading in time, that is delta x is leading the voltage by 248.57 microseconds. So approximately to the nearest 10, I would say 250 microvolts. So here I've put it here, the time that the current, when they are both at 0, the time that the current is leading the voltage is 250 microseconds when they are both at 0. When the voltage is 0 volt and the current is 0 amp, it's approximately 250 microseconds. Now let's look for the what is it called, the frequency. Now the frequency we will just use, so I will change both to let me change both. So I'll change 2 also to voltage, so that I can measure the frequency for either one of them, and the frequency for either one of them here is, we can see it from here. The frequency, that is 1 over delta x, is approximately 1 kilohertz. That is 986. So that is the frequency. That is the frequency. And we only need just 2 adjacent crests to do that. 2 adjacent crests to do that, and it's approximately 1 kilohertz here. Approximately 1 kilohertz. So the frequency is 1 kilohertz here, and it is 1000 hertz. So if we want to find the phase difference in angle, then it's this one here. That is the phase difference in time. Phase difference in time, which is 250 microseconds, divided by the periodic time, which is 1 microsecond, times 360, because for one cycle, for one complete cycle, that is where you have 2 adjacent crests. For one cycle, it takes 360 degrees to complete one cycle. So if I divide 250 degrees by, 250 microseconds, 250 microseconds by 1 millisecond, and I multiply by 360, it gives me 90 degrees. And this is how you can do to find the phase angle in degrees. But if you want to measure them, then you take 2 points like I've done here, and that will give you that one here. And exactly, so that is how you can do your calculation. Thanks for watching.